Hi everyone! In this video we're going to talk about rules of exponents. So these rules are really important and they come up over and over again when you're dealing with all kinds of math from this point on. So there's 8 main rules. We'll go through each one pretty quickly and hopefully they'll make sense. Number 1, zero exponent rule. This rule just says if you have a base raised to the 0 power, it's always 1. There is only one exception to this. 0 to the 0 is not 1. Other than that, every single number that you have, it could be any number, 5 to the 0 is 1. 5,731 is 1, okay, to the 0. If you have a negative though, just the negative stays, so be careful. This would be negative 5 to the 0 is negative times 1, so negative 1. Alright, and that is your zero exponent rule. Then you have your product rule, which says if you have a base to an exponent or power times the same base to an exponent or power, you can add those exponents. So this is a really nice rule. Let's look at a quick example. If you have 2 squared times 2 cubed, this rule says that this becomes 2 raised to the 2 plus 3 power, which is 2 to the 5th. Well, I picked small numbers so you can verify with me. This is 2 squared, which is 2 times 2. This is 2 cubed, which is 2 times 2 times 2. And if you count, well, yeah, that is in fact 2 to the 5th. So this rule checks out. Now, the one thing to mention on this rule, be careful, this is true if the bases are the same initially. So the base x here has to be the same base x here. The next rule is the quotient rule. Very similar to the product rule. And that's going to be if you have a base to a power divided by the same base to a power. What you actually get to do here is just subtract the exponents. So x to the a minus b. Now you just have to be careful as long as x is not 0, we can't divide by 0. So a quick example again for this one would be maybe 2 cubed over 2 squared. If you just expand this out, you'll see that the answer is going to be 2 to the 3 minus 2, which is 2 to the 1. Here's why. 2 times 2 times 2 is the numerator. 2 times 2 is the denominator. And then you can divide out. 2 divided by itself is 1. You can do that again. And you're left with 2 to the 1 power, which is 3 minus 2 on that exponent. So when you're dividing the same base, you can subtract the exponents. The next rule is the power rule. So if you have a base raised to an exponent, and then you raise that quantity to another exponent. It could be the same numbers, that's okay, it's just you have an exponent but with another exponent. This rule says that you actually multiply. So you have the original exponent times the new one, or the outside power. So an example for you here, let's pick small numbers again so we can expand this. Let's say 2 cubed quantity squared. So what this is saying is that I have 2 times 2 times 2 inside the parentheses, and on the outside I need to square that. So I need to have that same quantity twice. So if I expand this and I start counting, I have 2 6 times. And so the shortcut would have been for me to say from the beginning that this is 2 to the 3 times 2 power, or 2 to the 6th. Okay, so when you have a base raised to an exponent or power, and then you have that quantity raised to an exponent or power, you multiply. If you ever forget these rules, like let's say you confuse the power rule with the product rule, I recommend just doing a small example like I did with small numbers, and you'll figure out should you have added or multiplied. Number 5 here, our next rule is the product to a power rule. So this one is if we have, let's say, one base to an exponent, and then we're multiplying by a different base to an exponent, and then that quantity has an exponent. What you can do here, and I'm going to show you 2 steps because I recommend highly this second step, is you can think of it as distributing that power. So you have x to the a raised to the c power, and then you would do the same thing for y to the b. It's raised to the c power as well. And then based on the power rule that we just talked about, this becomes x to the a times c, and then times y to the b times c. So I did put an intermediate step in here, but I highly recommend that step because if you have like a negative base, let me show you an example so that intermediate step would pay off to do that. So let's say I had negative 2 squared times 3 cubed, and let's say that quantity is to the 4th power. Okay? So this rule says that if I'm multiplying inside this quantity, I can take this exponent from the outside and bring it onto both factors. So I have negative 2 squared, and that one has a 4th power, times 3 cubed to the 4th power as well. Now why I wanted to mention this is because this negative, it also is affected by the 4th power. So if I didn't do this step, I might have skipped the negative sign getting raised to the 4th power. So something negative, if you multiply any number times itself 4 times when it's negative, it turns positive. So that's why I wanted to make sure you see this intermediate step here. And so this becomes 2 times 4, so this is 2 to the 8th power. And then this becomes 3 times 4, so that's 3 to the 12th power. And then you can simplify this one a little bit more. You would actually put these numbers maybe in the calculator and figure out what do they actually equal in terms of this large number. Next rule, the quotient to a power rule, very similar to the product to a power rule. This time you just have a quotient, so you're dividing, let's say x to the a over y to the b, and that quantity is raised to the c power. Very much like we just did for the product, we're going to do the same with the quotient. So my intermediate step is that I have x to the a raised to the c power in my numerator, and then y to the b raised to the c power in the denominator. Think of it like distributing that c power to both the top and bottom. And then I would use my original power rule and say this is x to the a times c and y to the b times c. Alright, 2 more rules. The next one is pretty important. I want to make sure you understand this. So our negative exponent rule, I'm going to give you 2 versions of this because you actually need to know both. Let's say I had x to a negative power, negative exponent. Well, what this becomes is going to have an x in a denominator. Here's why, and I'll give you the rest in a second. Right now, this is starting with x not in a denominator. So a negative exponent, what it does is it's just like a message. It's saying move what it's attached to. So it's saying move your base x down to the denominator. Once you move it, you take off the minus sign. Then you can't leave nothing on top. So in this case, there's an invisible 1 on top that we have to write. That's one of 2 versions of this. The other version is if you were to start with your base in an exponent, in a denominator, and the exponent's negative. So let's say I had 1 over y to the negative b. The message is the same from the negative exponent. This negative exponent is saying move the base. So the y needs to move up to a numerator. Once you move it, the minus sign comes off. And technically there's an invisible 1 on bottom here still, but if 1 is ever in the denominator, you can just leave it off. You don't have to write that. So I would like to show people both of those because it just depends on where your base started. If it started in a numerator, the negative exponent moves it to a denominator. If it started in a denominator, the negative exponent moves it to a numerator. So let me show you an example of this because I see a lot of people mess up on this one. So take a look at this. Negative 2 x to the negative 2 power times y cubed over 3 to the negative 2 power times z to the 4th. Okay, so a lot going on in this example. What I want to first identify is which factors have negative exponents. And there's two of them, the x to the negative 2 power and the 3 to the negative 2 power. Why I want to pay attention to that is because that's the only factors that move. Everything else is going to stay where it's at, and so the negative 2 is on top, times a y cubed is also on top. So I can move the y cubed to the front here. Remember, multiplication is commutative. You can change the order. So I just move this y cubed next to the negative 2. On bottom, the z to the 4th is going to stay. Now, going back to what I had circled, x has a negative exponent on it, so x is in a numerator, so it needs to move down to the denominator. Once it moves down, take off that negative sign. It becomes positive 2 for the exponent. Similarly, 3 is in a denominator with a negative exponent, so 3 needs to move up to the numerator, and then the exponent becomes positive. And that would be the answer. We could simplify it a little bit further, but that's the main idea for the negative exponents. Let me just simplify it to show you. This becomes 9 times negative 2. So final answer would be negative 18 y cubed over z to the 4th x squared. Just another quick note on this one before we move on to our last rule. The negative 2 in the very front, that was just a negative number. That was not a negative exponent. So don't let this fool you to think you have to move this negative 2. This is just a negative number, so it just stays. The only thing that this is talking about is negative exponents. Only negative exponents move what they're attached to. They move their base. Last rule, the quotient to a negative exponent rule. So this rule says if I have a quotient, so I'm dividing, and the quantity has a negative exponent, well, think about what this is going to equal. If I were to bring this negative exponent onto the numerator term, that numerator would have to move down to the denominator. Same thing if this negative exponent comes down onto the denominator, the negative exponent part would have to make it move up to the numerator. So what's happening here is that the numerator moves down, the denominator moves up, and they flip. And then the minus sign comes off. So that is a nice rule once you know about negative exponents. All right, that is it for our rules of exponents. In the next video, I will show you some examples for using them.